How do hydrophobic substances work? So first, we're going to start off with what is hydrophobicity? How does it work? We're going to talk about hydrophobic, the difference between hydrophobic versus hydrophilic, and then we're going to have a summary of my experiment. So first of all, what are hydrophobic substances? So hydrophobic substances are pretty much just substances that repel water, and hydrophobic surfaces can be wetted easily. So if you look right here, there's a picture. And then, so a good example of like a hydrophobic substance would be a lotus leaf, because lotus leaves, they're really good at repelling water, but that's mainly because of the waxy surface that they have that kind of just like repels the H2O, the water. All right, so what are hydrophobic substances used in? So a lot of people use like hydrophobic substances in like almost anything. So you use it in like raincoats, umbrellas, waterproof jackets, anything waterproof. There's also hydrophobic properties in like non-stick cookware, like Teflon, anti-fogging products such as like goggles that you use to swim. And there's also automotive coatings, which is pretty much like your windshield, which they have a coating that repels the water. So how do hydrophobic substances repel water? So hydrophobic substances are nonpolar. However, looking at the way that water is H2O, it's polar covalent, so they don't necessarily react very well. Why is this? So nonpolar molecules can't interact strongly with a polar molecule's positive or negative end. So what happens when a polar molecule's negative end approaches a nonpolar molecule? The electrons are just repelled. So that's kind of what happens when they do like interact with each other. So when we look at a molecule like carbon tetrachloride, its structure is nonpolar because you look one on top, three on bottom, they cancel out. The electrons cancel out, the charges they cancel out. Then you look at H2O. H2O is one oxygen, two hydrogen. So you'd have two extra electrons on the top, and that kind of lead to more of a polar structure. So when you combine them, you'd end up with water right here and carbon tetrachloride down here, because carbon tetrachloride is a lot more dense than water. So it kind of just sink to the bottom and it wouldn't mix. So what's the difference between, let's say, a hydrophobic substance versus something hydrophilic? And what is a hydrophilic substance? So first of all, um, to measure something's hydrophobicity, you look at the contact angle. If its contact angle is greater than 90 degrees, then it'd be hydrophobic. But if it's greater than 150 degrees, it'd be super hydrophobic. So you may ask, what is a contact angle? So you look right here, and you're measuring from the bottom to the angle that the water droplet makes. So as discussed, something that is hydrophobic would be greater than 90 degrees, but something that's hydrophilic would be less than 90 degrees, as shown right here. So what was my experiment? My question was, how do hydrophobic substances work? So to start with, I collected an even amount of polar and nonpolar molecules, and then I compared them. I pretty much just measured the contact angle and then made a little graph. So my bar graph right here, it pretty much just shows my three polar and my three nonpolar. My polar was made of a glass bowl, napkin, and a towel. My nonpolar was a Teflon pan, styrofoam plate, and plastic Tupperware. So my results. All of my nonpolar materials pretty much repelled water, and the contact angle was greater than 90 degrees. But on my polar molecules, kind of the contact angle was a lot less. It was way less than 90 degrees. So it kind of showed that they absorbed the water and they didn't repel it as much as nonpolar. All right, that's it. Thank you.